Welcome to ICANCODENOW, and in this video we will discuss type qualifiers in C++. A type qualifier is used to refine the declaration of a variable, function, or parameters. They provide users with additional information about the properties of the variable. The type qualifiers in C++ do not change the meaning of the variables or entities with which they are associated. Type qualifiers are specified at the time a variable is declared. In C++, there are 4 type qualifiers: Const, which stands for constant; Mutable, Volatile, and Restrict. Let's talk about each. A const object or variable cannot be modified once declared. We cannot change or modify its value. If an attempt is made to modify a const object or variable, the compiler will raise an error. Since the value cannot be changed later, a value must be assigned at the time the variable is declared. This is the syntax for declaring a variable with the const type modifier. A volatile object or variable can be modified at any time during the execution of the program. The volatile qualifier declares a data object whose value can be altered in ways that are beyond the control or detection of the compiler, such as a variable updated by the system clock or another program. Variables marked as volatile typically change due to external factors, rather than as a direct result of the program's execution. Volatile objects are read from memory each time their value is required, and are written back to memory whenever they are modified. The value is not copied from memory to the CPU registers when a volatile qualifier is present. This is the syntax for defining a volatile object. The mutable type qualifier allows const class members, constants, to be modifiable. The mutable qualifier is typically applied to non-static class members of non-const and non-reference types. There may be instances where we need certain variables to remain immutable, unchangeable, while others can be mutable. In simple terms, once a member is declared as mutable, we can change its value at any time in the program code, even if the object created is of const type. This is the syntax for mutable. The restrict type qualifier is used with pointers, but does not inherently add functionality to the code. While it is a useful qualifier, it is not widely recommended by the programming community. There are alternative approaches that can be employed. Compilers can optimize code when the restrict keyword is present. This qualifier is typically used in function calls, where the programmer indicates to the compiler that if a pointer to an object is marked as restrict, then only that pointer will be used to modify the memory location it points to. This allows the compiler to perform optimizations. It is the programmer's responsibility to ensure that restrict qualified pointers are used as intended, otherwise, undefined behavior may occur. Below is the syntax for defining a restrict pointer. We will not delve into the details of the restrict pointer, but let's take a quick look at other qualifiers through code. Let's first create a simple variable, which I will name days in week. We know that the number of days in a week is 7, and we do not want to change this value at any time. However, we can assign it a different value if needed. To prevent this, we can use the const qualifier to make it a constant. Once declared as a constant, the value of this variable cannot be changed, and attempting to do so will result in an error. A value must be assigned when using the const qualifier, making it a requirement. The const qualifier can be applied to any data type, including float, string, or any other type. Once a variable is declared as constant, its value remains unchanged. This concludes our discussion on the const qualifier. Next, we will discuss the volatile quantifier. Let's declare a variable called age and assign it a value. When the value is incremented, it is updated. However, let's create the same variable using the volatile keyword. This time, when the value is incremented, it is updated, but the compiler has optimized the code to avoid saving the variable's value in registers. Instead, it reads from and writes to memory, RAM. The volatile keyword is used solely for optimization purposes. Let's discuss mutable member variables. These are used for class member variables that may need to be modified even when the object is declared as constant. To illustrate this, let's quickly create a simple class called foo, with 2 member variables, x and y, initialized with default values in the constructor. We will then create an object of the class named myFoo, which will have the default values of x and y through the default constructor. Now, Let's declare this object as const. When an object is declared as constant, any attempt to modify its member variables will result in a compilation error. This occurs because the compiler treats the member variables as constant as well. However, what if we want to modify the value of x while keeping y unchanged? We can achieve this by declaring the x member variable as mutable. By doing so, the error is resolved, and we are allowed to modify the value of x, while the value of y remains unchanged, as it is not declared as mutable. Let me quickly show you how a restrict pointer can be created in C++. We will go into the details of it in another video. Thank you for watching. I hope you enjoyed the video. Please leave a comment and I look forward to seeing you in the next video.